All right, so we have been talking about rational functions lately, and we have done quite a bit with them. We've talked about their domain, we've talked about their asymptotes, we've talked about how to graph them, we've talked about how to find their intercepts, general behavior that they have. The last thing that we need to do with rational functions is talk about their inverses. And so that's what this video is going to focus on. We're really going to talk about inverses from two different perspectives. And that's our two learning targets for this video. So let's take a look at those real quick, and then we'll get started. You can see the first thing that we have is that we're going to use graphs to figure out what the graph of the inverse looks like. So basically, we're going from graph to graph, graph of the function to graph of the inverse. And then for our second learning objective, we're going from equation to equation, equation of the function to the equation of the inverse. Okay, so this is the type of thing that we're going to be looking at in this video. And we're going to begin by looking at graphs. Okay, so here is the first problem that we're going to do. We're going to use the graph of f of x to create the graph of its inverse. Okay, now in this video, what I'm going to do is I'm going to show you the graph. I'm going to show you some points on the graph. And then we'll talk about how to use that. So since I already have the graph made, you don't have to worry about trying to create the graph, but you probably will want to copy it into your notes. Okay, so with that said, let me share with you the graph so that you can see what it looks like. And you may want to copy this into your notes. I would say that if you want to copy this, then probably graph paper is going to be best. And you probably want to make sure that you actually are copying these points that I've labeled on the graph for you, because those are the main features that we will use to help us find the inverse. Okay, now, so if you need to pause the video to do that, go ahead and pause the video right now and do that. All right, so hopefully you've got this graph copied, and hopefully you've labeled those points. The first thing I want to do is I want to talk about the fact that with this particular graph, we can't see for certain where the two asymptotes are. All right, so maybe let's take a look at the equation again for just a second. Here's our equation, y equals x plus 3 over x minus 1. And let's talk about the two asymptotes. So the vertical asymptote tends to be the easier one to find. We set the denominator equal to 0. If we were to do that, if we set the denominator equal to 0, we would get x equals a positive 1. And so I'm going to graph that real quick. X equals a positive 1. So there is one of our asymptotes. And just so that we don't get confused, I'm going to change the color of that so it doesn't look like it's part of our function. So let's make that purple. How about? Okay, so there's one of our asymptotes at x equals 1. Now let's take a look at what the other asymptote would be. Our horizontal asymptote, remember what we do is we compare the degree of the numerator to the degree of the denominator. In this case, both of them have a degree of 1. Remember, degree is the biggest exponent. They both have a degree of 1. And so what we do when the degrees are equal is we make a ratio of the leading coefficients. And so these both have a leading coefficient that's a sneaky ninja 1. So y equals 1 over 1, or in other words, y equals 1, is going to be my horizontal asymptote. So I'm going to graph that as well, y equals 1. And then same thing, let's change the color so we don't get confused here. We'll make that one purple also. Okay, so now we can see our two asymptotes. You may want to add those to your graph if you don't already have them. And we can see the two branches of the function, and I've labeled several different points. Okay, so what we want to do right now is we want to generate what would the graph of the inverse look like? What would the graph of the inverse look like? Okay, so to do this, the first thing I've done is I've copied those points from the graph onto my paper. So these are the exact same points that I had labeled on the graph. Now I've got them out labeled on my paper, and we're going to use this. So if you do not currently have these explicitly written in your notes, then once again, I'm going to ask you pause the video and get those written down, because we're going to use this list. All right, hopefully you've written that down. The other thing that we're going to use is we're going to use what our asymptotes are. And our asymptotes we found were x equals 1 and y equals 1. Okay, those were our two asymptotes. In this case, we're going to find that those are kind of very convenient asymptotes, but I'm getting ahead of myself. Let's start by looking at the table. So not last week, because last week we focused on rational functions, but the week before that, we talked about inverses. And we said that the very nature of an inverse is such that it's going to cause x and y coordinates to switch. And so if these are my x coordinates and these are my y coordinates, and I labeled them f of x, but remember f of x is the same as y, right? These are the same, okay? Y and f of x are the same, okay? So if these are my x coordinates and these are my y coordinates, then literally what happens when I look at the inverse? Literally what happens when I look at the inverse is everything that was a y coordinate becomes an x coordinate. So I can just copy all the numbers from the y column into the x column, okay? And then literally what happens to the x coordinates is they become our y coordinates. So it was -7 1/2, it becomes 1/2 -7. It was -3 0, it becomes 0 -3. For every single xy pair, the x and the y switch spots. And so now I have a table of values that I can use to make a graph. Okay, now with the asymptotes, the same thing happens. The x's become y's and the y becomes x's. So this was an x equals 1. The x becomes a y, and I end up with a y equals 1 from that asymptote. Okay. Similarly here, I had a y equals 1. The y becomes an x, and so I end up with an x equals 1. And so that's why I said a minute ago, these are going to be very convenient asymptotes because we actually end up with the exact same equations just by coincidence. It's not always the case. You can imagine if this would have been an x equals 2, then this would have become a y equals 2. And if this was still y equals 1, this would still be x equals 1. So it's not always the case that you get the exact same equations you had before. That's just a happy coincidence on this one. All right, so now I've got lots of points, more points than I need, really. I mean, honestly, you don't need to do this many points. And I've got my 2 asymptotes. So what I'm going to do is I'm going to take that information and transfer it onto a graph. And I just happen to have a graph here that's ready to go. So once again, if you need to, pause the video real quick and get yourself a piece of graph paper, get an XY axis onto it, and then we're going to graph our inverse. Okay, so ready to graph the inverse. What I personally do is I start with my asymptotes. And when we've talked about graphing, I talked about why it is I start with my asymptotes, but I'm going to go ahead and just count by 1. So 1, 2, 3, 4, 5 in that direction, 1, 2, 3, 4, 5 in this direction. I'm just going to count by 1s for my graph. Keep it nice and simple. And my asymptotes are both at x equals 1 for my vertical asymptote and y equals 1 for my horizontal asymptote. So I start by drawing those in. X equals 1 and y equals 1. So there are my 2 asymptotes. Okay, now I start copying over my ordered pairs. So these are the ordered pairs that we came up with after we switched the x's and the y's. So I've got a 1/2 comma -7. So over a half and then over a half and then down 7. 1, 2, 3, 4, 5, 6, 7 would be right there. Okay, I'm going to switch colors because I don't want my asymptotes and my graph to get confused for one another. So I'm going to switch colors. Okay, so there's that. Then I have a 0, -3. So 0, -3 is one of my points. And then I have -1, -1. So -1, -1. -3, 0, 1, 2, 3, 0. And now I jump over to some positive numbers. So I've got 5, +2. So 5, 1, 2. I've got 3, 3. So 3, 1, 2, 3. And I've got 2, 5. So 2, 5. 3 halves, which is the same as 1 1/2, right? 1 1/2, 9. So 1 1/2. And then 5, 6, 7, 8, 9. Okay, so these are the points that I have. And that is plenty to make it so I can see exactly where the asymptotic behavior is, right? So it's pretty clear that this is bending up along that asymptote that we found. This one's bending down along that asymptote that we found. And it also is relatively clear that it's starting to bend the other way. Even though I don't have quite as many points, it's pretty clear that it's going to bend along here and it's going to bend along there. And so there is the graph of my inverse, something that goes like this and like this. Okay, and so there's what we end up with. All right, so this is the basic idea of using a graph of a function to make the graph of an inverse. Now, I will say a couple things real quick. One thing that I'll say is because the inverse functions, or I'm sorry, the rational functions can have equations that are really quite complicated. In our class, we will probably save finding inverses using the graph for things that have very complicated equations. And we will do problems where the equations are more simple, where we use the equation method, which is the next thing that we're going to look at. Okay, so keep that in mind, is that when we're going with this particular technique, we can do relatively complex equations because all we need is a list of points, and then we're just going to switch those points. All we need is the asymptotes, and then we're just going to switch the x and the y in the asymptote. And that's all we're going to do, and we end up with a nice graph of our function. Okay, but we not only need to find graphs, we also need to find equations. And so that's the second thing we're going to do. And as I was starting to say just a minute ago, with these types of problems, we'll tend to limit ourselves in our class to equations that are relatively straightforward and not too complicated. Okay, so if you compare these two examples, example 1 and example 2, this equation is definitely more complicated than this one. Okay, and so we in our class probably won't do much with trying to get the equation of this inverse, but the equation of this inverse I think is pretty reasonable for us to do. So let's think about how does that work. Well, if you remember back when we studied inverse functions, we talked about the first thing you want to do is whether you actually write it or whether you just, be cognizant of the fact, just be mentally aware of the fact that g is the same as y. And so we want to think of this as being a y. And the reason why that's important is because really the first analytic step in finding the inverse is to do exactly what we did with the graphs, switch the x's and the y's, because that's the nature of inverses. They want to switch the x's and the y's. So I'm going to take this y and turn it into an x, and I'm going to take this x and I'm going to turn it into a y. The rest of my equation stays the same. Okay, so strictly speaking, we now have an equation that represents the inverse. It's not in the proper format, but that represents the inverse. Okay, so if you don't have those notes from when we did this before, or if you just need a reminder, we remember that g of x is the same as y, and then we switch the x's and the y's. Now we're going to solve for y. Okay, now with this, there's a lot of different ways you can solve this. Different people think of it different ways. I think my favorite method goes back to like we talked about last week. Think of this as a rational equation. Well, it is a rational equation. But think of it as a rational equation where the x can be written over 1, and then I can just cross multiply. So if I cross multiply here, I'm going to get an x times a y. And if I cross multiply here, I'm going to get a 5 times a 1. Okay, so I end up with xy equals 5. Now, remember, my goal is to solve for y. I'm trying to get y by itself. So right now, the y is being multiplied by x. If I want to get y by itself, I have to think about what undoes a multiply. Well, division undoes multiply. And I'm multiplying by what? I'm multiplying by x. So therefore, I need to divide by what? Well, I need to divide by x. And so I'm going to divide both sides by x. And that's something in our class we haven't done very much of. It's rare that we divide by a variable, and usually we're dividing by numbers. So this is something that sometimes students get a little weirded out by, but in this particular situation, it's okay to do. So I end up with a y over here. And over here, of course, 5 and x, because they're not like terms, they can't really simplify or anything. So I just get that, x over 5. And then I change it back into function notation. So there we go in function notation. Okay. So this is our basic process. This is our basic process. We're going to replace the y, or the g with a y, switch our x's and y's, solve for y, and then switch back into function notation. Remember, once we have the inverse, we use the little -1 to represent that. Now, if we back up for just a second and look at this whole problem as a whole, there's something that you should definitely notice. Function g was equal to 5 over x. And function g prime, or I'm sorry, g's inverse is also equal to 5 over x. This is a really strange situation, something that we've never come across in our class before. The function is its own inverse. In other words, this function cancels itself out. If I were to put 5 over x into the function 5 over x, they cancel each other out. It's kind of funky. It's sort of weird. It's something we've never seen in our class before. Now, I will say this does not happen for every single rational function, but it obviously happens with this one. And so we need to watch for that and be prepared for that when it does occur. Okay, let's do one more with equations, because I think that we want to be ready for things that are a little bit more complex or a little bit more complicated than just simply that. So here's example number 3. Let's say that I've got h of x over or equal 2 over x plus 1. H of x is equal to 2 over x plus 1. Now, here's what I would ask. Pause the video and try this as far as you can go. If you get stuck somewhere, don't try and force it, don't guess, then just resume the video so you can make sure that your notes are correct. But try this and see how far you can get before you get stuck. Maybe you'll make it all the way to the right answer. I don't know. But pause the video now and see what you can do. Okay, so hopefully you've paused the video and you've given this a fair shot. The first thing you should have done, right, is replace the h with a y. And then you should have switched your x's and your y's. That should be our first thing. Okay, now for the next thing, we said we were going to treat this like a rational function where I put the x over 1 and I cross multiply. So when I cross multiply, I'm going to have this. And now I'm going to have to distribute in order to get rid of those parentheses. All right, so now let's think about how am I going to get the y by itself here? Well, what I'm going to need to do is first get rid of this x at the end. And that is being added on to y. So what gets rid of addition? Subtraction does. So I'm going to subtract an x from both sides. When I do that, these x's will cancel out. That leaves me with an x times y. And over here, I get 2 minus x. Now, I can divide both sides by x, just like we did on the last example. And when I divide both sides by x, I get these x's cancel, y. And over here, what we typically do is we just leave this as a big fraction. Because remember, the only way I can cancel is if the x goes into both of these. And even though the x does go into this x, the x does not go into the 2. So because it doesn't go into both of them, I really can't cancel. So I just write it as a big fraction. And there's my rational function. And now I change it back into function notation. And there's my function notation. Okay. Now on this one, notice that h of x and H's inverse are not the same. Obviously, they're related. There's a connection. They both have a 2 and things like that, but they're not the same. Not like example number 2, where they literally were exactly the same. Okay, so these are the types of problems that you'll be working with in tonight's homework. Finding inverses from equations, like example 2 and example 3, and then also finding graphs using other graphs, like example number 1. All right, so that's it for this video. Thanks for watching. Have a good one.